Hi everyone, welcome back. You're watching Math with Anila. In the previous class, we have studied about different trigonometrical ratios. Today, let's see the relation between different trigonometrical ratios. The first one is the reciprocal relation. We know that sine A is equal to opposite side by hypotenuse and cosec A is equal to hypotenuse by opposite side. So if you compare these two, we can say that cosec A is the reciprocal of sin A and sin A is the reciprocal of cosec A. Therefore, we can say that sin A is equal to 1 by cosec A or cosec A is equal to 1 by sin A. This is the first reciprocal relation. Sin A is opposite side by hypotenuse and cosec A is hypotenuse by opposite side. That is, one is the reciprocal of the other one. Similarly, cos A is equal to adjacent side by hypotenuse and sec A is equal to hypotenuse by adjacent side. So here, if you are comparing these two ratios, we can say that cos A is equal to 1 by sec A or sec A is equal to 1 by cos A. Cos A is the reciprocal of sec A or sec A is the reciprocal of cos A. In the same way, tan A is equal to opposite side by adjacent side and cot A is equal to adjacent side by opposite side. Therefore, we can say that tan A is equal to 1 by cot A or cot A is equal to 1 by tan A. Tan A is the reciprocal of cot A or cot A is the reciprocal of tan A. These are the reciprocal relation. We have seen three reciprocal ratios. Sin A is the reciprocal of cosec A or cosec A is the reciprocal of sin A. Cos A is the reciprocal of sec A or sec A is the reciprocal of cos A. Tan A is the reciprocal of cot A or cot A is the reciprocal of tan A. They are reciprocal to each other. Sin A to cosec A, cos A to sec A and tan A to cot A. Next is the quotient relation. We know that sin A is equal to opposite side by hypotenuse and cos A is equal to adjacent side by hypotenuse. When you divide sin A by cos A, we get sin A by cos A is equal to opposite side by hypotenuse divided by adjacent side by hypotenuse, and that's equal to opposite side by hypotenuse into hypotenuse by adjacent side. So instead of dividing with a fraction, you can multiply with its reciprocal. Reciprocal of adjacent side by hypotenuse is hypotenuse by adjacent side. So both the sides hypotenuse get cancels. You get this as opposite side by adjacent side. So as per the relation, we have seen that opposite side by adjacent side is equal to tan A. So we get sin A by cos A as tan A. Sin A by cos A is equal to tan A. That is one of the quotient relation. Now, let's divide cos A by sin A. Cos A by sin A. So, cos A is adjacent side by hypotenuse divided by opposite side by hypotenuse. And that is equal to adjacent side by hypotenuse into hypotenuse by opposite side. hypotenuse and hypotenuse get cancels. You get this as adjacent side by opposite side. And as per the relation, we know that adjacent side by opposite side is quot A. And this is the next quotient relation. That is cos A by sin A is equal to cot A. So, sin A by cos A is tan A and cos A by sin A is cot A. These are the two quotient relation we are getting. The next is the square relation. Consider triangle ABC with angle B is 90 degree. And here we know that this is the hypotenuse. AC is the hypotenuse. Since the side opposite to 90 degree is AC, it is the hypotenuse. Now let's consider sin square A plus cos square A. To find sin square A plus cos square A, we need sin A as well as cos A. Sin A and cos A. See here, we are finding sin A. That means A is the angle of reference. If A is the angle of reference, BC will be the opposite side and AB is the adjacent side. Now, when you write sin A is opposite side by hypotenuse. So, the opposite side is BC by the hypotenuse is AC. In the same way, cos A is adjacent side by hypotenuse. That is AB by AC. This is what we are getting for sin A as well as cos A. And sin square A plus cos square A is same as sin A the whole square plus cos A the whole square. And that's equal to sin A. What is sin A? BC by AC. BC by AC the whole square plus AB by AC the whole square, since cos A is AB by AC. That's same as BC square by AC square plus AB square by AC square. Since the denominators are equal, we can add the numerators. So that is same as BC square plus AB square upon AC square. Now, what is BC square plus AB square? BC square plus AB square. We know that this is a right angle triangle. So, since it is a right angle triangle, we can apply Pythagoras theorem. So, Pythagoras theorem says that the hypotenuse square AC square is equal to BC square plus AB square by Pythagoras theorem. That is hypotenuse square is equal to base square plus altitude square. That is a Pythagoras theorem. So from here we get the value of AC square as BC square plus AB square. So let's replace BC square plus AB square by AC square. We get this as AC square by AC square, and that is equal to 1 since these two get cancelled. So we get sin square A plus cos square A is equal to 1. Therefore, what we can say? Sin square A plus cos square A is equal to 1. This is one of the square relation we are getting. So we have got sin square A plus cos square A is equal to 1. From this, two more equations we can make. That is sin square A is equal to 1 minus cos square A. Bring this cos square A to the other side, keeping sin square A is on LHS. So we get sin square A is equal to 1 minus cos square A. Similarly, keep cos square A is on the same place and shift sin square A to the other side. We get this as cos square A is equal to 1 minus sin square A. These are the square relation with respect to sin and cos. So what are the relations? Sin square A plus cos square A is equal to 1, or sin square A is equal to 1 minus cos square A, or cos square A is equal to 1 minus sin square A. So the next one is 1 plus tan square A. Let's find what is 1 plus tan square A. Here also the angle of reference is A itself. So angle of reference is A. This is the opposite side and this is the adjacent side, and AC is the hypotenuse. So let's write this as 1 plus tan A the whole square. So that is equal to, what is tan A? Tan A is opposite side by adjacent side. So we can write this as BC by AB. BC by AB is tan A. We write this as 1 plus BC by AB the whole square, since this is tan square A or tan A the whole square. So when you simplify this, you get this as 1 plus BC square by AB square. By taking the LCM, this implies AB square plus BC square upon AB square. Here I have taken the LCM, AB square is the LCM, and here you need to multiply AB square with 1. 1 into AB square is AB square plus BC square. So AB square plus BC square by AB square. Now as per the Pythagoras theorem, AB square plus BC square is AC square. That is equal to, instead of this AB square plus BC square, we can write AC square by Pythagoras theorem, and that by AB square. And this is same as AC by AB the whole square. And what is this AC? AC is the hypotenuse. AC is the hypotenuse by AB is the adjacent side, the whole square. So what is hypotenuse by adjacent side? And that is same as CK. CK the whole square. That's equal to sec square A. This is the next square relation we are getting. That is 1 plus tan square A is equal to sec square A. So we got 1 plus tan square A is equal to sec square A. So from here we can find tan square A is equal to sec square A minus 1. Bring 1 to the other side. Or 1 is equal to sec square A minus tan square A. So these are the other two relations we are getting from the first expression, that is 1 plus tan square A is equal to sec square A. Now you can prove this square relation, that is 1 plus quad square A is equal to cosec square A, and find the other two expression from this equation or from this identity. So we have studied about reciprocal relations, quotient relations and square relations. So we can say that each of these relations are the trigonometrical identities. That's all for today. We'll meet in the next class with more sums on the same topic. Thank you.